Right, so now we've got the last solid principle, which is dependency inversion. So I'm going to just do dip.ts in here, and then I'm just going to bring in the explanation. So essentially, dependency inversion principle is high-level modules should not depend on low-level modules. So they both should depend on abstractions, and abstractions should not depend on details. So details should depend on abstraction. So this one's quite a lot to unpack, but what is exactly happening is we should basically separate out our dependencies from each other. So an example of this is using dependency injection to pass a notification service to a component rather than the component creating and depending on a specific implementation. So if I just read that again, because this one is quite difficult to understand. So using dependency injection to pass a notification service to a component, this is the key part here, rather than the component creating and depending on a specific implementation. So now it'll make more sense when I show you the example, but essentially this increases decoupling because it's separating out your logic from what you render. So this is what we look at in a React example. It improves testability because you're separating all of this stuff out instead of having a React component that essentially has a use effect in there that does some logic to fetch a component and so on. Then it renders detail in the JSX. What you want to do is have a use hook or something that does the fetching for us. Then we can essentially pass that into the component, and then the component is just simply worried about what it renders. So that is what that is. So again, it improves testability. So decoupled modules are easier to test in isolation since dependencies can easily be mocked or stubbed. And then it also enhances flexibility. So it allows for easier swapping for implementations without affecting the high level logic. So because we're flexible now, because everything is all handling again another responsibility, which is the single responsibility, is handling all of that logic, then you can kind of add on change the logic if you needed to as well. So this is good for like changing features or adding new implementations into projects and so on. So what I'm going to do now is bring in an example of a bad approach without dependency inversion. So let me just bring in this example and paste this in. So you can see here that this is going to be an email notification, and that's the low level module. So basically send email is the low level module, and this is the high level module, which is basically the notification service. So you can see here the higher level module is to notify the user by email, which is again the low level module, and then that basically console logs sending email and then the message that we pass in. So the high level module is notify user, hello, this is a notification, and then the output is sending email, hello, this is a notification. So that's what essentially gets logged out at the end of this whole chain here. So high level and then low level. So this is without dependency inversion. So I'll put in here dip, and then let's just comment this one out for now, and then let's bring in the example or the good approach that we should be using. So this makes more sense. So now in this example, what we do is we introduce an abstraction. So here we have two low-level modules. One is the email notifier and one is the SMS notifier. So basically email notification and SMS notification. So if we go back to the top, here you can see high-level modules should not depend on low-level modules. So basically now we've separated that this is an email notifier and this is a SMS notifier. And then the notification, which is the higher level module, is not dependent. So you shouldn't worry about whether it's an SMS or it's an email. It should just worry about notifying the user. So that's what it's supposed to be doing. So all it does is it takes in a notifier like so, and then the message. That's it. So the notifiers are these SMS notifier or email notifier, and then we also have the interface, should I say, in here that the calls a method of notify like that. So in our email notifier, it calls notifier, which is obviously the type that it expects, which is a message or string, and then it returns type of void because we are console logging. So this is the same for the SMS notifier in here. So the high level module, we are notifying the user, and then the low level module is how we are notifying the user. So in this example here, we are notifying by email. So this will be the message, sending email, and then here we are doing it by SMS because we are passing in the notifier type in here, which is SMS, and email in here. So this is how you would separate low level modules from high level modules. And this is dependency inversion in a nutshell. Let's just quickly skim through it and the pros. You can see here it increases decoupling. So we decoupled the notification from how they are receiving the notification. Then we improve testability because decoupled modules are easier to test because we can test whether it's a SMS notifier or an email notifier. And then also it enhances flexibility. So again, if you wanted a different notifier like mail notifier, we can add that in as well. And then so extend it further. So adding in the other principles that we've talked about, they now have single responsibility. It is interface segregation because we are expecting this to be a notifier. And then it is open as well, open close principle, because we can extend this SMS notifier now. Or the email notifier, we can add in the mail notifier, or I don't know, the whatever this the application notifier. Is all using the same solid principles, and this in general will also help you improve your application. So essentially dependency inversion enables us to build more adaptable, testable, and maintainable software as well. So that is the last one. So now all it is a case of trying to practice with these examples that I've given you. Essentially, if you apply all of them or some of them to your projects, then your code will be more robust and scalable. It probably is going to help you improve as a developer and also maybe increase your chances of promotion because you are implementing some best practices that we should all be implementing in our code bases. And also, on top of that, once you practice these, try and implement them, try and teach them, try and help other people learn with these. And essentially, this will make your life easier as well. So, anyways, I hope you enjoyed this video and learned a lot from it. Please like and subscribe, and then I will see you in the next video.